So hello everyone, and thank you for having me. I've been so much fun to meet all of you, and thank you for WG1 to organize it as well, making the connection. Yesterday we also had a presentation in Mitsubishi Industries, and you were my second, and you tried to, when there were questions, and you also was very kind to translate that to Japanese. So I don't mind if something has to be translated to Japanese, but you said all these gentlemen speak English, so ladies as well. So anyway, if there's any additional technical questions, don't hesitate just to ask. So I have a very small agenda for today. We already started with welcome, and I have a small, I think it will take around 50 minutes from now, so we might be a little late, but that will be all right for you. So I'm going to talk about the common language for engineers. Then I would like very much to discuss about ISO IEC 81346 in brief. While I remember it, I will try to speak slowly to make sure that because when I get enthusiastic, I speak fast. So if I'm too fast to say, hey, easy now. Okay. And then I would like to show you how we actually use the standard in real life. So it's not just theory, but I will actually give you some real life examples. One is from a public project in Denmark, and the other one I tried to connect with some of our existing customers, but most of them says, no, this is confidential, and so we have to create our own example, which we actually use for demonstration purposes. But it's a very nice example, and I also hope I can do a live demo of how we actually work with it, so you can see it's not that far. And I think it would be nice to discuss about 81346 in tools. I have some useful links for you, and I've updated the presentation WG1 so you can distribute it later on. And we have the debate, and then we will close up and go out and something to check. That was it. So briefly about myself. My name is Balslev. I have a background in high voltage electrical engineering since 1988. And I would say, like you, I have been joining ISO and IEC standardization since 1996. That's in IEC TC3 and in ISO TC10. Like in Japan, in Denmark, we are very privileged to have both ISO and IEC in the same organization. So like we have JSA here in Japan. In Denmark, we have Danish standards, and they host both ISO and IEC. And therefore, I can just turn my head whether I want to be an IEC or want to be ISO. It's the question of being flipping around. It's very useful. And I would wish that it was like that in the rest of the countries. If you go to our neighbors, Germany, it's divided into two organizations, and it gives a lot of bonus, to be honest. I hope that people will remember me for being practical and daily life oriented. We have clients who works with us every day, and we don't teach this, we actually do it with people. So I hope that people will remember me for being practical in daily life. Besides that, I have received the IEC 1906 award twice for my contribution to this international study. Just one slide about our company name, Systems Engineering. I don't know if you're familiar with that, but that is a way of handling complicated projects. And we do a lot of different projects in our company. We have from medical devices. I think I need to use my pointer here. Yeah, from medical devices, complicated test plants, a lot with green energy and electricity. We work for Airbus since 2017, no further introduction needed, and then the rest of them as well. What they have in common is that they actually fully believe or actually use the 81346 standard already. So thereby I also said that you are not first movers, but you can be fast followers. And it does a lot of good things for you. But just to say, this is also the range of different industries that actually can benefit from that international standard, which we are very happy about. We are situated in Copenhagen, and you can be reversed on the internet if you found that useful. So that was the beginning. And then I will go on with my presentation about 81346 and what that's about. Am I speaking slow enough? Is that okay for you? Yeah. So otherwise I'll slow down. So we are actually on a mission, and I say we and my company, and me especially, I would say we are on a mission, and that is to create what we call a common language for engineers. It's very ambitious, I know, but on the other hand, I hope that when we leave each other tonight, that you will see that it's actually possible to have a common language for engineers across different silos. There is another industry which already has a common language that they cannot live without, and that is within music. And that's actually international. So if you can read keys and notes, does anyone of you read keys and notes besides me? You read music keys and notes? No, then we can't play together. Sorry about that. But the whole idea is, of course, that musicians have keys and notes. And that means if you just have a small band like this one, or musicians, they could actually rehearse and play together without having keys and notes. But when the music gets complicated or long, they cannot live without keys and notes. So let's give our 4 friends some keys and notes here, and now they can start playing together. When it's just 4 persons, it's a small group, it's an uncomplicated thing, but I'm sure you can imagine if we switch to this photo, and we have over 80 people who have to play together for 2 hours, complicated classical music without doing anything wrong, they need a common language. And it's the same vision that we have started with the 81346 standard series. That's why we call it a common language for engineers. Now, there is a premise you need to buy in on to understand the 81346 standard, and that is that we think in systems. Now, what is a system? Well, let's start from the big end. If we take the beautiful A350-1000 aircraft here on this maiden flight, this is my favorite photo from Airbus. We have assisted Airbus in converting and identifying the systems of that aircraft from scratch. It's already built, it's already flying, so we did reverse engineering on it to understand what's going on. And of course, it's obvious that it has a control system, and it has a navigation system, and it has a rudder system, a lift system, an elevator system, and so on and so forth. But it's a way of organizing the complexity for digital purposes in Airbus, and this is why we've done it. So it should be quite obvious that you can understand the complexity like an aircraft by dividing it into systems. I couldn't help finding this one since yesterday. So if you have a robot like you have, in fact, if you look at it and if you look in the data sheet, it actually says robot system. So I would say I'm on the right track, especially being with you, ladies and gentlemen, here today, that you are actually a part of thinking in systems. And that is the key to understand 81346. Just to underpin what we're doing, human beings are in fact divided into systems as well. Officially, we have a digestive system, nervous system, skeletal system, etc., etc. We have in total 11 systems. So it's not that strange, it's actually inside us. It's a way of dividing complexity. So this is actually the first takeaway. 81346 defines systems for you. A little bit about the background. You know probably as well as I do that ISO and IEC have this double logo discussion going on, and whether it's an ISO, an IEC, or an IEC ISO. Well, it depends on who you ask. I mean, if you ask ISO, it's an ISO 81346. If you ask IEC, it's an IEC 81346. But to be honest, the industry doesn't care. They just give it to us. So in my handbook and in the way we present it everywhere, we just call it ISO and IEC 81346 because it is a double logo standard, and all the internal discussions they have, to be honest, we disregard that and say this is it. So that's why we call it ISO IEC. It belongs to ISO TC10 and it belongs to IEC TC3. A little bit about the history. I'm not going to take long, just to say that it originates from a need we had in electrical engineering originally, where there was a need to designate circuits, so you know when you were switching the right circuits. So originally there was a need for having a relation between the documentation and the switches, so you can see how you're operating. In 1996, the 61346, which was an IEC standard, was born. And in this one, they introduced something called aspect thinking and structuring. And I've been a part of the standard since 1996. I still remember the day in Danish standards where we got the message that ISO wanted to join. So in 2009, the standard was become a double logo standard, Part 1 and Part 2. And you probably know as well as I do that it's regularly maintained. And that's the good news about this standard, that it's regularly maintained. So even though it's a quite old standard, it's still developing. There's still a lot of updates in it. So you can actually trust it a lot. In 2018, we started to introduce what we call industry-specific parts. And the story is long. Maybe we can discuss that over a beer tonight or whatever. It's a long story why we ended up there. It came out from a strong need in the construction sector to have a common language for construction needs. It was a very hard and tough debate about it. The paradox is that without that debate, we would not have been able to make it as simple as it actually is today, which can discuss that later. Part 12 has become the mother of the foreign parts. So we have the new Part 10. This came in 2022, which is for power systems, anything related to power and power generation. We have Part 14, which just came out, which is anything related to manufacturing. I think including robots, but it's not necessarily like that, but anything related to manufacturing. Then we have two important new ones coming. We have Part 50. Part 50 is about processes, which means what a system is doing for you, moving things, gluing things, or what a human organization is doing, validating, and discussing, calculating, and things like that. So that's a new one in the standard series. Then for data, we have a new Part 8 coming about properties. It might surprise you a little that we have put that into 81346. The fact is that there are at least 4 or 5 other initiatives going on worldwide regarding properties. But to be honest, we think that become too complicated. And as a consequence of that, we have simplified it to fit in the spirit of 81346 and how that works. I will not talk about that today. That will take too long. But just to say, when you know the spirit of 81346 and you see how Part 8 handles handles properties, and you can see that we have simplified it dramatically compared to how other people are doing it. Finally, but not least, we have a new Part 20. I'm the project manager for Part 20 coming out, and that's going to handle about vehicles, anything that can fly, anything that can drive, and anything that can sail. So as you can see, the standard is growing. I had a meeting with Japanese standards this Friday, and it seems like in Japan, you are a little bit stuck with the 61346 parts. So they promised me that very soon they will launch 81346 Part 1 and 2 here in Japan as well. So I think with all the things going on, they realized that, and they were very happy to accept it. So regarding the simplicity, and this is where I think some of the ontologies starts to work. So we have created a way of thinking with letter codes. So we have something called 1-letter codes, 2-letter codes, and 3-letter codes, and it reflects to a size of a triangle. And the triangle has become an essential part of understanding of how 81346 works, and I will show you that in a little moment. But the whole point is that, as you can see, Part 2, 10, 12, 14, and 20 is organized the same way in a triangle. And likewise, we have spaces where can you find things, where they're useful, where can I go and find things. And it's also organized in a triangle philosophy. And finally, but not least, we have the processes which are also organized in this triangle philosophy. And just to look a little bit behind the scenes, in the systems, we talk about 3 different kinds of systems. We talk about prime systems, we talk about technical systems, and we talk about component systems. And just to be practical, I don't know if you can see me online, but if I'm taking my mouse here, this is considered to be a component system in the context of 81346. And the reason is, of course, that a system is something that is comprised of elements, in this case, click buttons and a wheel and a chassis and batteries, which makes up a larger whole. If you are used to thinking systems, that's obvious for you. But to new beginners, it's a kind of aha experience that this is actually a system. And likewise, we aggregate it to larger wholes. We have around, in total, sorry for this, we have around 650 component systems in total. And that covers, I know this is a little bit controversial, but these 650 component systems covers everything you can imagine. Nothing is missing. And how we managed to do that, I'll show you that in a moment. So around 650, which is actually quite simple. It's quite banal. Last time I counted, around 120 component systems belongs to electricity, and similar to mechanical engineering and so on and so forth. So it's a small number share. Technical system is when you aggregate them to larger wholes. That could be, for example, a pumping system or a transformer system, or things like that. And prime systems is typically the entry point. So, but system thinking is the key. 1-letter code for farm systems, 2-letter codes for technical systems, and 3-letter codes for component systems. And I'll show you my examples a little later how it's actually working. Likewise for spaces, we are talking about construction complexes, we talk about construction entities, and we talk about spaces as such. And when we switch to processes, we have prime processes, activity processes, and task processes. And you can put this together in any way you like, so you're not limited to 3 levels, I assure that. But this is the repository. The interesting thing, maybe for you, is that all these systems have a definition. So we don't just have names, we actually have specific definitions. And we have, last time we counted, we have over 2,500 definitions included in that standard. And I'll show you why these definitions is the key to have a common language, both in English and Danish and Japanese, and I'll show you that in a moment. Does it make sense so far? Yeah. I'm not going to give you a long speak about 81346 works, but I think I need to show you at least one little slide about what the whole idea is behind it. So there are 3 things you need to know if you want to work with 81346. First of all, we have something called aspects. And aspects is a way of sorting out information to make them more clear. This is a little old one. We actually have 5-6 aspects today, but these 4 aspects are the core aspects. We have something called a functional aspect, something called a product aspect, location aspect, and a time aspect. And the only thing you need to know for now is that aspects is a way of sorting out information so they become clear. That's what they're using for. And you will see some examples later on how that actually works. Then we have the basic idea with the triangle, which goes hand in hand with making a breakdown. So the whole idea with the breakdown is that I can say I have a computer, sorry, I have a mouse, also called a component system, and it's broken down into sub-elements like a chassis, click buttons, batteries, and stuff like that, which is what the figure to the right is showing. So you can break down any complexity you like, including your robots. It's a very straightforward way of doing it. But 81346 has a certain syntax for how you do it, and thereby you cannot just make any kind of breakdown. You can make breakdown you like, but there are some limitations which makes the quality good. Finally, but not least, as you can see here, we are trying, I don't know if you can see it on the screen here, but it says over here, it says functional model, product model, and process model, and you make some breakdowns. And we have a big drawing I can show you later on. And the whole point is that you make things break down, which makes things clear, and then you relate them to each other to understand how they work together. And with this in hand, and with this tool in hand, you can express any kind of complexity you like. It's a very, very powerful way of expressing that. And it's made with this common language. When you put all that together, you have something called a reference model. And I'll show you why it's called a reference model in a moment. So, back in 2012, in the Danish construction sector, we had an issue with a door, because there seems to be a lot of discussions about what is a door actually. So we decided to introduce definitions in 81346, and the first that struck our mind is that we need to make it simple. So in 81346, a door is a door. It's not more complicated than that. So the reason for this is that when you see in different other, especially within the construction sector, you see that they try to predict a lot of doors, inner doors, outer doors, made of steel, made of wood, size, length, weight, and stuff like that. And they try to combine all these properties to a library, and it's not possible because it just grows and grows and it becomes a mess. So don't do that. So we took the opposite direction and say, to us, a door is a door. How do we make a door a door? We did it like this. So this was the key to introduce definitions. So we have a hierarchy in definitions. For those of you who are interested in ontologies, it's a type overlation. It's actually a classification system. And here we have broken down class Q into subclass QQ, and class QQ is subdivided into class QQA, QQB, QQC. And as you can see for them, we have the definitions going on here. So in this case, QQC, according to 81346, is defined as a space access object for offline access by persons, also called a door. Now you might think, all right, no big deal, but it took us 4 years to figure that out. So it was not easy. It was not easy. The elegant part is that if you translate this to Japanese, and my apologies if the Japanese is semi, but I think I asked for a quick translation. Yeah. So we translated the same thing to Japanese, and the whole point here is, I hope it makes sense, sort of at least. Yeah. The whole point is that if you translate 81346 to Japanese, as long as you use QQC, everybody knows, including me in Denmark, reading your designations, that you talk about now. That's the whole idea. So the language in 81346 is robust, for it can be used for multi-languages purposes. It's actually transparent. As long as you stick to the coding principles, we have a common language. And since there's a definition behind it, the quality is very good. So you can probably do better translation than that. But the whole idea is that if you translate the libraries of 81346 to Japanese, I can understand them, even though I don't read Japanese. All right, let's go to the reference model. So let me take another example. I'm a little in love with Lego, which you can probably see. Oh, that's okay for you. This is Lego Duplo, and by Lego Duplo, I made an example with a little aircraft. Yeah, very rough sketch. If we zoom in on the propulsion system, the thrust system, which is creating the thrust for the aircraft, if you did a system breakdown according to 81346, it would look like this. So we have a thrust system, which is broken down into traction system, engine cooling, you can read yourself. And then we entered into the combustion system, and that one is also big, so we expand that to the oil filter systems and stuff like that. Maybe you remember the 1, 2, and 3 letter codes idea from before. So that means when I'm looking at a 1 letter code, this is the prime system. When I have a 2 letter codes, these are technical systems, and 3 letter codes are component systems. But when you build the model, there's nothing wrong about having a technical system and a technical system, and so on and so forth. You can also have a component inside a component. So there's no limit to the complexity that you can express. You simply just go ahead and subdivide. Sometimes you also have components inside components. For example, a door, if you think of it. A door is actually a complicated system. It's not just a door, it's actually a door leaf and a glass and a handle and a lock and so on and so forth. So in the world of 81346, it's actually a door system, which is made up of all the things I just mentioned. So this is a way of creating that kind of model. The good news is unlimited, so you can build anything you like. And since I'm with you, ladies and gentlemen, dealing with robots, of course you can designate robots and whatever that robot is doing, including the software. So we have this coding principle. So if you haven't seen this coding principle before, the first time people see it, I think it's a little strange. So equal in one means that we are thinking functionality, and we're thinking functionality about the thrust system in this case. If I want to address the combustion engine later on, I do like this. And if I want to go further down, I just continue like that. That code is not possible to understand upfront. You need a decoding mechanism to understand it. But that said, when you are used to the coding principles and you start working with it, it's not a big deal. And then please remember there are classification systems behind them. So M has a definition, MS has a definition, ULN has a definition, and so on. Oh, by the way, I forgot to say also for the remote audience that it's a slide number here, 20 in the bottom. If you have questions later on, you could note down the slide number and we can get back to it. Sorry, I forgot to mention that at the beginning. So what is that about the common language? So if we take our reference model from before, and let's assume we have a mechanical engineering silo. And let's assume we also have an electrical engineering silo. Very often people say, let's break down the silos. But actually, I don't believe in that. I believe in people staying in the silos and having a common language instead. This is much more effective. So we leave our mechanical engineers in their silo with their drawings, and we take our electrical engineer in with their diagrams and schematics. But the whole point is, as long as they refer to the same thing, they are talking about the same thing. It's as easy as that. So this is what the whole idea is about. And this taxonomy can also be read by machines. It's machine readable and it's also human readable as well. So when we talk about a common language, we talk about that, of course, you need to learn the language, but it's not that complicated. And thereby people can stay in their silo. They don't need to change anything. They don't even need to change their IT tools at all. I'll show that in a moment. And then they can actually start literally to play together, engineer together. Regarding tools, and we will spend some more time on this, but regarding tools, what we see with our clients is that they have a lot of different tools. In this case, it's just a handful of different tools. Some of it is made in 3D, and some of it is made in diagrams. Some of it is made by assembly process diagrams and things like that. And what we see is that they try to connect these different kinds of tools to each other point to point. As far as we can see, that is pretty hopeless, because you're trying to connect point to points which are very, very different. So what 81346 actually offers instead is that it says, well, if you connect to the central reference model, thereby you have a gateway, so you can connect the 3D model to the, for example, the physical view, and the diagrams to the functional view, and inside the model you can relate them to each other with a specific meaning. So the whole idea of 81346 is that you can use it as much as you like, but it actually allows you to connect very different models inside your engineering portfolio to actually talk about the same thing. And I think that's pretty elegant, if you ask me. This is what Airbus realized back in 2017 when they called us and said, we think 81346 is the key for our digital revolution, and we want to include that in our future work. Let's meet and see what we can do together. And as we say, the rest is history. We are still working for these fantastic manufacturers. Let me zoom in a little bit so you can see what's going on. I also have a very big drawing. We also bought it. Yoshi is on the wall down there for people who are present. So when we have a break, we can have a look. But for those of you online, I will also show it. So this is the idea. This is it. Then it's time for use case, some practical stuff. So let me show you how we actually actively use 81346 in a really large-scale public project. If you do robots, I think this might be a little bit too large for you, but on the other hand, it's just to show there's no limit. So, as you know, I'm from Denmark, a small country far north from here, close to Germany and between Norway and Sweden. And in Denmark, we have, of course, cities like you have, and this is the largest but one university city in Aarhus. Next to the harbor, very beautiful city. My favorite, besides living in Copenhagen, I really love Aarhus. And they are going to build a new waste treatment and energy plant. And the reason is that the city is growing, so they need more volume for the wastewater. They also want to build an upgraded version where they actually produce energy out of the wastewater. And finally, there are some strong demands for the environment that the water shall be even more clean than it is today when they put it into the bay. And the client has become a good friend of us, so we started to, they actually called us and say, Henry, you did 81346 for us for a long time ago. We would like to update it, and we would like to use it in this project as the way of organizing system thinking in this project. So you can just read for yourself what that project is about, and then I will continue in just 2 seconds. So the key to break down that standard, the key to that one is that we are introducing 81346 as the key to a lot of things. And I would like to show you now that we use 81346 for when you have created the reference model. We use this for a lot of good stuff, and I think there are 2 things in it that might have your interest as well. It looks like this. You can read for yourself. This is the menu, so to speak. Reference destination, system architecture model, connecting different models. But I think that interface management, how things interact with each other, might be something of relevance for you. I don't know if you have issues with your interfaces, but this is a very nice way of controlling interface. I'll show you that in a moment. And also working with requirements is a must-have in terms of systems engineering. And it was not so that the client said this upfront. This is a very good idea. We want to do that. It took us 1.5 years to convince him to say this is what we're going to do together. And today they have decided now they go all in for this way of thinking. And let me show you a little example of how we actually do it. So this is to be honest, I've never seen a diagram like that until I saw it first time. It turns out that it's an architect who has drawn it and not an engineer. So when an architect drawing houses is going to make something nice, they draw it like this. But I have to accept it, so I'm sure you can get the point. It's not an engineer, it's an architectural drawing instead. It's very nice. I think most people get it. And what we have done in it is that we have divided the plant into subsystems. And the good thing about 81346 is that it automatically gives you the borderlines of the systems. And the reason for that is that it has these definitions. So with the definitions in hand, it are actually possible to make borderlines and thereby find out where does the different kind of systems actually cut, which is a very important thing. We can also zoom in on G4. And as you can see, we use 1 and 2 letter code techniques. So the 2 letter codes are just technical systems and so on and so forth. So these are the diagrams, but in the model, it looks like this. So we have organized all the systems together with the engineers from the client. We have organized that. And if we zoom in on this one, then you can see what's actually going on inside. I think the elegant part here is that I can introduce you to that plant in less than 5 minutes, and you will have an idea what's going on. It will not take any longer than that. It's actually smarter and more easy to do it like this than try to make diagrams and stuff like that. This is somebody every engineer understands. Straightforward. The way that it's subdivided is coming directly from the standard. You can see that different letter codes, and all these letter codes has definitions. You can also see we can still call it exactly what we like. I had a little funny thing with the client, because I said to the client, he's a good friend of mine, so I said to him, you have to accept that if it's not here, if it's not written here, you're not going to build it. It doesn't exist. And then he said, oh, but there's a lot of things which is not in there. Yes. So you have to put it in to make sure that you are in control of it. So it's also a way of organizing your complexity. So he said, oh, but what about bicycle lanes? What about we also have a small house for scouts, stuff like that. Well, that's just a system of a system, so we can put that in as well. So the whole matter of this is a little old version, but as it is today, we have introduced a lot of the systems, and we have maybe around 50 total systems that has to work together on the top level. And without this technique, they would have been lost. Does that make sense? Yeah. So you can become experts in wastewater in less than 15 minutes by just looking at it. So I would like to introduce to you a very nice thing. I don't know if you're familiar with something called the N2 diagram. No. The N2 diagram is an old story. It originates from 1974. It's a way of making a map of different kind of interfaces. So you can look it up on the internet yourself. Just search for N2 diagram, and you can see for the information later on. It looks like this in reality, and the whole idea is that you list your systems in the diagonal 1, 2, 3, 4, 5, and the rule is that outputs goes in this direction and it becomes an input in this direction. So that means in reality, the inlet system has an interface to the mechanical pre-treatment system. And the external sand and sludge reception has an interface, it actually has 2 interfaces to the mechanical pre-treatment. And the mechanical pre-treatment has an output to the external swing here. So I don't know if it makes sense for you, but the whole point is that this N2 diagram has become extremely popular in our projects because it's a very nice way of overlooking all the interfaces. If the idea is that all systems are listed in the system breakdown, here you can see the interfaces among the different systems. And as you can see, there are some letter codes. That means that instead of just saying that we have a relation, we have specific meanings. We have electrical transfer of energy, we have cooling, heating, we have space, we have signals. And we have identified there are around 30 interfaces in total for an engineer you need to be in control of, and that's it. But the good news is if you put it in here, you are in control of it. And I was not aware that when I originally introduced this, but it turns out that 81346 goes fantastic hands in hands with this way of thinking. And the reason is that you have things that are comparable with each other due to the mechanism of the 1 and the 2 and the 3 that goes. You do not compare a component system with a big system. You compare big systems with big systems, minor systems with minor systems, and components with components. It's a very, very, very effective way of avoiding stupid coordinating mistakes. It's very powerful. Yeah, I think due to time, I'll skip these ones. We can always get back to them, but I would like to show you use them for these ones. So just to mention that requirements in this project, how the project is supposed to work, it's quite obvious that requirements are linked to the technical systems. That means specifications are organized the same way. It would take too long to explain how we actually do it, but it's interesting to see that the client realized stepwise that they needed to do something specific, because otherwise requirements is just left in some documents nobody wants to have a look at. But in this way of organizing, it becomes very structured. Everything has a place, and it's very easy to see if all the requirements are related to a system or not. But I think that will take at least a year to discuss that later on, so let's keep that. All right, use case number 2 is a little bit more, even more low case. I did before I left for my 81346 tour in Japan, asked one of our clients if I can use their system breakdown as an example here in Japan, and the answer was, no, it's confidential, you can't do that. So you have to excuse them, we have to create our own example, which on the other hand, you can distribute and use as much as you like. You can use the old event because that's a public Danish project. But I would like to show you that what we are doing now is that we had in my company, because I've been working with this standard so long, I simply had to invest in creating our own tool. So we have created a web-based public tool where you can actually play with these system breakdowns and you can play with the interfaces. And like everywhere else in the world, AI has also come to Denmark. We have to look at how that works. And it has turned out that AI is a match made in heaven for 81346. It can really accelerate your journey into that way of adapting it super fast. And yesterday I took the chance to make it live demo. Maybe I'll do that today as well, but I need to explain what's going on first. So this is the coffee machine. We took it from the internet from an Italian manufacturer. I actually met with an Italian engineer not so while ago, and he was very keen on this Italian coffee machine. So I'm sure that you can imagine what a coffee machine is like. So the whole idea is that instead of trying to figure out from start, you typically have some kind of data already. For example, a BOM list or a diagram or a 3D drawing, whatever. And we are working hard to make sure that by using our own AI design, we can actually easily create a system breakdown based on that one. And I think I will take the risk and see if we can do it live just to show you some practical stuff. So I'll risk it in a moment. Just want to see how much more, there's not so much more to do. So I think we got time for that. So first of all, we have I'm logged in already. We have a commercial tool called 813 for the SecOp, and that's about system engineering. As you can see here, we can do system breakdowns. But since AI is we are playing in the AI sandbox because we are not completely safe around it yet. We want to make sure that when we release it as a part of our software, we have to guarantee that it actually works. So we are still playing in the sandbox how it works, but I would like to show you our sandbox and how effective it actually is, and that's the live demo. So regarding AI, you probably know that as well as I do, the more context you can give to AI, the better it becomes. So the first thing we need to tell our AI demo here is that I'm working on a coffee machine. So, then it says, all right, give me some data that I can work on. And in this case, it was just the BOM list from before. And this is a stupid Excel sheet, fat Excel sheet, nothing more than that. And now it imports it here. And as you can see here, these are all the things in just a long list from the BOM list. Now, it's quite obvious to say to it, please go and find the 81346 codes for me. And what's going on here is that we have identified that we need a technology where we have two different AI systems competing with each other, because it's actually guessing they are trying to guess what's going on. And these two AI systems are competing to see if they can find the same code. And then we have a third AI system, which is validating if the input is right or wrong. And as you can see now, it came up with the coding principles here. So do you remember the 3-letter codes from before? So it has found all the component systems for me here. And when it's green, it's because the two different AI technologies have agreed on it, and we have the third one which has justified that it's okay. And when we come further down, okay. Oh, this one, this disagreed. And here I need to pilot it. Here I need to say to it, you either need to fill that one or you need to take that one. And I need to pilot it by saying, I use this one. There's one more. In this case, I could say, I actually wanted to use, and as you can see, holding collecting interface object of surplus. When I am holding my mouse over here, these are the definitions from the 81346 standard that is displayed for me. So I don't have to guess. I just have to compare if the definition fits. So I pick this one, and then I approve it, and so on. And with this in hand, now comes the super magic. I think we say, all right, let's take the next step. And we are currently experimenting because we've done these structures so many times. So we have made a prompt for our AI systems. So we can actually try to guess how the systems look like in the background, just our AI. Here it goes. Or the alternative is that you can also give it a diagram or whatever you have in hand to emphasize what's actually going on. As you can see here, it comes with a system breakdown, coffee machine system, supply system, blah, 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 blah. You can read that yourself down. And what's missing now are the final coding. You can see we over the 3-letter codes, and it has guessed that this is a prime system and this is a technical system. All right, go and find the rest of the codes for me, please. You still need to validate the output. You still need to validate the output. You still need to validate the output. And what we have found out is that we have, it's not done yet, but we are asking our system to prompt with the rationale behind why it did as it did. And with the rationale in hand, along with the system breakdown here, we think we have a pretty good case to actually validate if the proposal for a system breakdown is good. And with this in hand, feed this into our system. And then it looks like, hopefully, it doesn't like this already. So I loaded it, I preloaded it until, so I had to cheat a little bit out. That's okay with it. It's still there. So over here looks like this, and the only thing that has happened now is that we have put numbers on it. And now you can play with it linear here, and you can start validating it and so on and so forth. So, oops. That's because it locked me out. Sorry, you're not supposed to see this. The whole point here is that just half a year ago, we had to do this by hand, but I think having the definitions, having an AI system, having the knowledge, I think we have lowered the burden of going from something, existing data, and actually creating this kind of information. And we think we expect one out of it. And we think the whole idea about having AI to do the hard work for you, and then you can start validating the system breakdown is a very nice way of working. So we have actually 2 clients who said this is a good idea, and they are feeding us with real data. I think the point here is we keep this data in our hub, even in the client's hub, so we don't share that externally. We don't launch that to the big internet. So it's disappearing to somewhere it's not supposed to disappear. We keep it this way. All right. So that was a mini live demo, and time is flying. I think I've got 10 more minutes to go. I just want to show that I have some more regarding software, and then I have some hints for you of where you can find some more information, and then it's time for debate afterwards. So in your case you think that this 81346 is a good idea for you, we also very often ask about, all right, but we got a landscape of existing software already. How does it actually adapt 81346? How does it actually do it? And as far as we can see, there are a number of things you need to know. So this is just to show the idea. We have a reference model in the middle. And then we have a lot of different kind of systems around it. Polarian, which is a requirement management, PTC, which is a 3D model, etc., etc. And the whole idea is that we want to have this one as the reference point, and to be able to have that, you need a way to integrate with these software tools. We have identified that there are 3 different types of software that you need to handle, and they behave quite differently. We have what we call high-level description-oriented data, which is basic stuff like Google Drive and SharePoint and just documentation, things stored in a document. Then we have something which is component-oriented, which are things where you can actually store data next to an object. And finally, but not least, we do have some diagram tools which automatically can create these 81346 code principles as well. Let me take a quick tour through it. So first of all, very banal. Excel and Word, whatever kind of documentation and spreadsheet systems you have. In this case, it's ours. You need to introduce that. And the way you do that, very simple, is that you just add 2 additional informations out here. RD stands for reference destination, and you also need a unique identifier in here to make sure that you're talking about the same thing. And then you simply just hook up these documents to a certain point in the reference model by doing so. It's as easy as that. So it's a relatively easy task to do it, to know where to hook it up. If we take to the second level, what has to go on in here, this is a 3D design tool, PTC is called. Then in this case, you can have a dedicated property related to reference destinations inside, but you still also need a unique identifier to know what you're talking about. It's just to say that within these fields, you can easily add fields around it, but you need an external code to come from a sensor place, for example, our tool. This is another example of the same Polarian. It's a way of making system designs with specific another language. And this one, you simply just add a third way of relating to the reference destination as such. As you can see, the same thing going on, reference destination, here we go, and unique identifier here, so you know what you're talking about. That's also a way of making sure that you're talking about the same object in the databases. Finally, but not least, here, sometimes systems like diagrams tool. I don't know how you do diagrams in Japan and with what kind of tools, but typically the best tools can generate reference destinations themselves, because it originates from electrical engineering. And in this case, this is ePlay. This is a German company that we also have as an integrated point. When you insert transformers and motors, it automatically generates the reference destinations for you to the left side, which then has to be synchronized with the reference model as well. So we actually don't think, of course, it has to be done, but it's not that complicated, and you can actually introduce it without changing anything in your existing systems, but just adding something. So you add an additional layer in your existing systems. That was a super quick tour regarding software. We can always get back to it in the questions. So I just got 2 more slides to show you, and then it's time for debate. First, we have our own homepage, 81346.com. I was lucky 15 years ago, I bought that domain by coincidence. We try to share free stuff on it. We try to keep it non-commercial. So if you go there, you can sign up for free newsletters and for free material you can download, and you can follow the development of the 81346 standard in a central point. And we very often, at least 1 or 2 times a year, we invite for free webinars that you are more than welcome to join as well. If you want to learn more about it, we are happy to say that in YouTube there are some existing videos. We have created our own channel about 81346. We have 7 training videos, and these videos have over 70,000 views. Last time I counted, I think they're hitting 80,000 actually. And it's a small series of 6 small movies that introduces you to the basic technique of 81346. And since it is an international standard, you can also find some of our friends from Norway and Sweden and elsewhere, which are actually putting YouTube stuff as well on regarding 81346. So there's plenty of things you can have a look at. We have created an app. Also, we have an app for our phone. It's made in by acceptance from the Danish standards, by the way. So we just couldn't create it, speaking about having support for it. So we created an app with a lesson from Danish standards. And if you go to these QR codes, you can download it, and then you can start searching for the coding principles. And finally, but not least, our software tool is available as a commercial tool if you want to start store and explain it, but you can actually do it in a platform if you like to. And that was it. Thank you so much for your attention.